Okay, today's starter is this. We have an asteroid, and it's known to have a circular orbital radius that is 4 astronomical units away from the sun. And 1 astronomical unit is the distance, the average distance from the sun to the Earth. So anyway, so that's like 93 million miles or something. So what is the period of its orbit in years? Okay, so let's give it a shot here. Given, well, I like to draw a picture of it. So here's this. So maybe this is the Earth. Well, this is 1, 2, 3, 4 times the radius of this orbit is 4 times the radius of the Earth's orbit. And now that's not the radius of the Earth, that's the radius of Earth's orbit. So make sure you keep that in mind. And that's all we're given. And it's circular orbit and so on. So this is the sun, and that's 4 times. And what are we trying to find? We're trying to find the period for the asteroid. So let's solve. Now, we do have an expression, that's Kepler's third law. And pi squared equals, now I can't remember this, I think it's 4 pi squared over gm times the radius cubed. Is that right? Oh, I'm off screen. Thank you for letting me know. Let's zoom out. Thanks for letting me know. All right. But I don't want to have to deal with all this stuff. So here's what I'm going to do. I'm going to do this as a ratio. And I'm going to say the period squared for the asteroid, well, that's equal to 4 pi squared over gm times the radius of its orbit cubed. But the radius of its orbit cubed is 4 times the radius of the Earth cubed. See how we did that? 4 times the radius of the Earth cubed. Now, I'm going to divide that by the period of the Earth squared. Maybe T sub e. Now, what is that equal to? So, well, that's equal to 4 pi squared over gm times the radius of the Earth cubed. And this, again, the radius of the Earth's orbit, not the planet. Ugh. All right, so now look, the nice thing about setting up the ratio is, guess what goes away? Almost everything. All right, so the 4, the pi squared, the g, the m, even the radius of the Earth goes away. Everything cancels out. Awesome. So we can say that the period of the orbit of the asteroid squared is equal to 4 cubed times the period of the Earth squared. Okay, so now what is the radius, or what is the period of the Earth? Well, we want it in years. So this is going to be 4 cubed times 1 year squared. Well, what is 1 squared? 1. So we're going to take the square root of this, of both sides here, well, of everything. Take the square root of both sides. So we get the period of the asteroid is equal to the square root of 4 cubed and times 1 year. Well, let's see. 4 times 4 times 4, that's kind of the crude way to do it, is 64. And take the square root of that. We get 8. So the period of the asteroid is 8 times 1 year is 8 years. You all agree with that? Did you get that? Now, This is going to be on the AP test, but it'll be on the AP test as a multiple choice question because they know that if you know how to set it up with simple ratios like this, everything cancels out. So, so you don't really need a calculator. Well, I used a calculator. I didn't really need one though. Because, yeah. But anyway, any questions? Okay. That is all.